In this lesson, we're going to take a look at some algebraic expressions. And the first thing I'd like to go over is evaluating algebraic expressions. So let's just start with an example. If I want to evaluate the expression 3x squared minus xy for x equal negative 2 and y equals 4, that means I need to put negative 2 in everywhere I see an x and put a 4 in where I see a y. Now we follow our order of operations, parentheses, exponents. Negative 2 times negative 2 is 4. Then I'm going to multiply. 3 times 4 is 12. Negative 2 times 4 is negative 8. Finally, minus a negative becomes plus a positive, and 12 plus 8 is 20. We can do the same thing in examples B and C. Let's see, P is 12 and X is 2. So I plug those numbers in. The fraction bar is like a grouping symbol. I have to actually do the computation on the top and on the bottom, and then finish by dividing. In the numerator, I get 144. That's 12 times 12. In the denominator, I'm going to work inside the parentheses first. 2 plus 1 is 3. 2 times 3 is 6. And then I'll finish by doing the division. 144 divided by 6 is 24. Feel free to type that into your calculator if you'd like. But keep in mind, if you forget a calculator, you are going to have to do that by hand. All right, part C. A is 20, B is 5, C is negative 2. I plug all those numbers in. And once again, I have to think about my PEMDAS. Inside the parentheses first, 5 plus negative 2 is 3. Then I do the exponent. 3 squared is 9, and 20 times 9 is 180. Now, as the expressions we work with get more complicated, we are going to have to use a calculator to evaluate expressions. And we're going to have to be a little bit careful about how we enter things into our calculator and how we do some rounding. So in example 2a, we're going to evaluate the expression. So I'm going to start by just plugging numbers in. So I put in 200 for p, 0.05 for r, 12 for n, and 120 for t. Now, in many calculators, you can actually just enter this in one line on your calculator, but you have to be really careful with how you use parentheses. On my calculator, these are the keystrokes that I can use to enter this expression directly into my calculator. I've pulled up an online calculator, and you can see in the screen, or in the calculator screen, the keystrokes I pressed. On this calculator, I had to use that X to the Y button. Some calculators have that caret button for the exponent button. And I'll hit enter, and there's my answer. The directions said round to the nearest hundredth. That's 2 places after the decimal, so 329.40. I round down because the digit after the 0 is smaller than 5. Now, you don't have to enter these expressions one or all at once. You can do the individual parts separately using order of operations. But you do have to be a little bit careful. So let's say you go into your calculator and you type in 0.05 divided by 12. You might get something that looks like this. What's happening is you're actually getting a repeating decimal. Those 6's actually repeat forever. And so when you do the computation with that number, you want to add 1 to that. You have to be careful. You don't want to actually round this number. It might introduce rounding errors into your problem. And so if you want to do the computation like this, you're going to need to keep lots of those digits, all of those digits in your computation. I think it's going to be much easier to do it all in one step, and you don't have to write things down and worry about rounding incorrectly or making mistakes when you write down numbers. Let's do one more that's pretty complicated. I'm going to start by plugging in the numbers that were given to me. R is 175. Little r is 0.08, m is 12, and n is 360. So I'm going to work out everything in the fraction first, and then I'm going to multiply that by 175. If I wanted to enter this expression in one line into my calculator, I would have to type in the keystrokes that I have written down in red. Notice I have to have parentheses around the numerator of that fraction and parentheses around the denominator. That's telling my calculator that that fraction bar is a grouping symbol. I have to compute everything in the numerator first and everything in the denominator. Here's another online calculator. This one is through Desmos. I really like this calculator a lot because I can visually see what I'm typing in. Unfortunately, most of the calculators that you can bring to class and use on tests and quizzes aren't going to look like this. But it might be a great way to check your work when you're doing your homework and make sure that you're actually typing in the keystrokes that you intend to. So I typed in exactly the keystrokes that I had written down in the notes, and then I can see my answer over to the right. It says round to the nearest hundredth, so I round down again, 0.90, and so there's my answer, 260,812.90. Now every calculator is a little bit different, so make sure you practice doing these problems on your own calculator, whatever calculator you plan on using during exams. Finally, the last thing I'd like to do with algebraic expressions is talk about simplifying them. If we have addition and subtraction in an expression, we can only combine like terms. That means we can only add things that have the same variable part. Combine like terms, we add the coefficients, and the variable part doesn't change. So in example 3a, the like terms are the 5x and the minus 4x. Notice that I always put subtraction as kind of a negative attached to the number behind it. That allows me to work in any order. So 5x minus 4x, well 5 minus 4 is 1, so I would get a 1x, and then the minus 10y, there's nothing we can do with that. Now, a coefficient of 1, you don't have to write that down, and in fact you shouldn't write that down. So I would write my final answer as x minus 10y. There's that imaginary 1 in front of the x. And again, I can't go further with this. The x and the y aren't like terms. They can't be combined. The same idea is true in part B. I'm going to combine the a's by adding or subtracting their coefficients. 6 minus 15 is negative 9. So I get a negative 9a. And then I have a 1b minus 8b. That's going to be a minus 7b. And once again, the a and the b aren't like terms. We can't go any further with this. Now we can multiply things that are different. We don't need to have like terms to do multiplication. With multiplication, you can multiply in any order you want. Negative 4 times 3y cubed is a product of three things. To do that multiplication, you just multiply the negative 4 times the 3, and that gives you negative 12y cubed. Finally, if you want to multiply by a sum or a difference, we have a distributive property that says the multiplication will apply to each term in that sum or difference. So in this case, I have to multiply the 2 by the 4x and the 2 by the 3y. That gives me 8x minus 6y. Once again, these are not like terms, so I can't go any further. We can combine ideas in part E. I'm going to start by distributing the 5. So 5 times 2x is 10x, and then we get a plus 5y. And then I have to distribute the negative 3. Notice I have to distribute both the 3 and the negative. That gives me a minus 3x, and then minus 3 times a minus 5y is going to become a plus 15y. A negative times a negative is always a positive. Or another way of thinking about that, when you distribute a negative, it changes the sign of all the terms. Now in this problem, I actually can go further because the 10x and the minus 3x are like terms, as well as the 5y and the 15y. So to finish, I combine my like terms. 10 minus 3 is 7, so I get a 7x, and 15 plus 5 is 20 plus 20y.